In this video, we're looking at Unit 4, Lesson 8, and we're starting off with problem 8.2, which deals with a flag-raising ceremony at a 4th of July event. So here they give us 6 different graphs that represent the height of the flag as a function of time. Now remember, that means for us that the height here is our output, and time here is our input. It's always output as a function of input. Now we're going to look at a couple of these graphs in this video, and you can think about the rest of them on your own as a little bit of practice. So if we look at graph A here, we are asked to just think about what does this graph tell us about the flag. And the first thing I notice is, well, we start on the ground here at the beginning, and going forward from there, we go up at a constant speed or a constant rate. We can tell it's constant because it's a straight line. And then at the end of our graph, we are up here at around 6, whatever those units are, meters or feet, after around 5 seconds. For graph C, which is the other one we're going to look at, this one also starts at the ground, and this one goes up pretty quickly at the beginning, but then it actually slows down, and even right in here, the flag stops. Right here, the flag is no longer going up. Its height stays the same for a little bit. And then it starts to go up faster and faster again until it gets to the top of the flagpole after about like 3.5 seconds. Now the second part of this problem here asks us to decide which of these graphs looks realistic and which ones don't. And this is a little bit up for discussion, but I'm just going to look at one of them as being kind of unrealistic, which seems to be graph D. Now, if we look at this graph, what it's telling us here is that our flag goes up and then down and then up and then down and then up and then down over and over and over again. And I don't know about you, but I can't think of a reason why they would be doing that at the flag raising ceremony. One last part of this problem gives us one more graph to think about. Now, in this graph, what I notice is that we're only dealing with one time throughout the entire graph, and that is 3 seconds. So this means that our flag is at a bunch of different heights, all at one time, 3 seconds. That is actually not possible to happen if you think about real life, so this graph could not be an actual representation of the time and height of the flag, because we're at a bunch of different heights all at one time. And if we think about the second part of this question, is this a function? Well, the answer here is again no, because we have multiple outputs, which is height, for one input, time.